Alrighty. Hello, Internet. Let's get my drum beat down. Goodbye, drum beat. Hey, happy Thursday. You're back here with Joey. Everyone loves math. Live show, Monday through Thursday at 9 o'clock, where we just do math on Twitch, man. So I'm going to talk about... I'll talk a little bit more about myself in a few minutes, but I did get some questions on the Everyone Loves Math hotline, and so I figure that Stove and I... Stove, how are you doing? I didn't say hi yet. So Stove and I are going to do these problems, couple problems, little college algebra, yeah, we're going. So hey, check out this first problem. Can you tell that I didn't want to write the word concentration? So the first problem, c of t, which is this rational function, 1 over 7t squared plus 1. So this thing represents the concentration of a drug after t hours. And the first question, I got this off of the hotline. The first question asks us for the horizontal asymptote. So the very first thing we got to remember is the horizontal asymptote is all about end behavior. So remember, horizontal asymptotes and vertical asymptotes have nothing to do with each other. So we want to make sure to separate those in our heads as far apart as possible. Horizontal asymptote is about end behavior, and another way to say end behavior is we look at large values of x. Because when x is large, that'll tell us what's happening at the end of the graph. So, I'm going to do, what I've done before. I'm going to put, 1 million in for, and in this problem, instead of x, it's t. So in this problem, what we're going to do to consider the horizontal asymptote is I'm going to look at c of 1 million. All right. I'm not even going to write it out. I'm just going to put 1 million. Oh, you can't see that. There we go. See, I wrote c of 1 million, and then that equals 1 over 7 times 1 million squared plus 1. All right, so we got to ask ourselves, what kind of number is 1 over 7 times a million squared plus 1? What kind of number is it? Oftentimes, until we get to calculus, the answer is looking at us right in the face. So this thing is really like, if we had 1 million in for t, the numerator would be 1 and the denominator would be huge, right? I don't know what number that is, right? 1 million squared times 7 plus 1. That would be 1 over some huge number. And 1 over a huge number would get very close to 0. If you have a fraction with 1 divided by a bazillion, that would be a number very close to 0. So what we would say in this problem is we would say that the horizontal asymptote would be the line c equals 0. Because for large values of t, the output gets very, very, very close to 0. All right, so I happen to know that this was a multi-part question. So, Stove, now that we got part A, I'll just have you, you can put in the Twitch chat what part B is if you want to type it. Or you can just snap a picture and send it, whichever one works for you. But since we're helping Stove, I'm going to wait just a second to get Stove's part B. Oh. Oops. All right. We did part A, and we're waiting for part B. Waiting for part B. there we go. What happens to the concentration of the drug as T increases? Okay. Yeah. Oh, as C increases. What will the What? Oh no, you wrote all kinds of stuff. Stove. Let's see. Okay. So determine what happens to the concentration of the drug as T increases. Yeah, send me a pic. Send a pic for part B. It was hard to read in the chat. Operators are standing by. I probably should make like some holding music or something, you know, for when I'm waiting on like a pick. I make some funky like on hold music. I got it. I got what you sent, Stove. Let's see. All right. Determine what happens to the concentration of the drug as T increases. As T increases, what value will C of T approach? All right, man. So, yeah, I was afraid they asked that. Okay. Stove, the answer to that next part, we already answered it. As remember what we did up here? It asks what happens as T increases. So what they're asking about is like, you know, what's happening as T is getting bigger and bigger? Well, we plugged in a huge number. As T increases, as the variable increases, the denominator keeps getting bigger and bigger. The fraction is 1 over some huge number. So what we would say here is we would say that as time increases, the concentration will approach 0. That's what the horizontal asymptote means. That if this really does model the concentration of a drug over time, then the math tells us that over time, the concentration of the drug would go to 0. Now that would also make sense for a patient, right? You know, if you take aspirin over time, the amount of aspirin in your bloodstream would go to 0, but it also works out mathematically. Does that make sense, Stove? Oh, you did part C. Look at you. Look at you. All right, so we'll do that other question that you asked? So Stove put these questions in the Everyone Loves Math hotline. That's that number that's showing up. Oh, I got to point this way. On my little scroll, 727-371-6464. Everyone Loves Math hotline. You ask a question, it's going to get done. So here was Stove's other question. Stove's other question is find the intercepts of this graph. Okay. So a couple things we noticed, just we'll call them out. First thing we know is this is definitely a rational function because it is a quadratic over a quadratic. The other thing that like I cannot help myself when I see this, like I cannot help myself. The numerator and denominator are both differences of two squares, and you got to be like a hawk when you see, ooh, that's a perfect square minus a perfect square. Even if I don't need this for the rest of the problem, I'm going to just factor it so I have that information. Because x squared minus 16 is x plus 4x minus 4. And x squared minus 9 is x plus 3x minus 3. Okay, so it's intercepts time. And I think they want the x-intercepts as well as the y-intercept if they exist. So let's start with the y-intercept. All right. We're going to do that first. I'm going to do it in green. Let's find the y-intercept. So the cool thing is the definition of y-intercept from like algebra 1 will take you all the way through calculus. The y-intercept is where x equals 0. That will never not be true, man. The y-intercept is where x equals 0. So in this problem, if we're going to find the y-intercept, then I'm just going to put 0 in for x. And when I do, I could put 0 into this function, the x squared minus 16. Let me give you some more space there. So that x squared minus 16 one, I could put 0 in for x here, or I could put 0 in for x here. I'll just do it, let's see, in this first one, because we would have negative 16 over negative 9. You know what I'm saying? If I put 0 in for x. 16 and 9 don't have any common factors, but negative over negative is positive. So the answer here, we could say y would be 16 ninths. Or another way to write this is we would say the y-intercept is where x equals 0 and y is 16 ninths. All right, so we're halfway there. Next up, we find the x-intercepts. So the x-intercept is always where y equals 0. All right, I'm going to put that in a box. Those things are always true. So what I'm going to do is I'm going to set y equal to 0, except because I know where we're going, this time I'm going to use the factored form when I did that factored form. So we would have x plus 4, x minus 4. I'm just copying it from above. I'm copying the factored form because that's going to be easier to answer this problem. So a lot of people will even get this far and then freak out because they don't know what to do. So here's the story. I want to walk this through and make this simple. First of all, x-intercept is where y equals 0, just like the y-intercept is where x equals 0. First things first. All right, second things second. If you cross your eyes and look at this thing, we have got a fraction equal to 0. And you got to ask yourself, when does a fraction equal 0? And if you think about it, a fraction equals 0 only in the case where the numerator is 0. So what we really have to do here is set the numerator equal to 0. And from here on out, we can probably do this in our heads. X equals negative 4. That would make the first factor 0. And x equals positive 4 would make the second factor 0. So this problem, there are two x-intercepts. The x-intercepts are at negative 4 and 4. Or the way that we can write that kind of officially is we could say the x-intercepts are at negative 4 comma 0. Because remember, x-intercepts are where y equals 0. And positive 4 comma 0. That's where the x-intercepts are at. All right, Stove, how does that look? If all they're asking is intercepts, then you got to take advantage of that, right? Y-intercept is where x equals 0. X-intercept is where y equals 0. Put 0 in, and then plug and chug. All right. Here we go. Do. All right. So, Stove, if you got any other ones, send them into the hotline. I'm going to take a second and have a little commercial break. So let's talk for just a second. Hey, what's up, internet? Yeah, send them in. So, while Stove is sending in more questions on the hotline, I just want to point out a couple things, like the fact that, hey, I've got a website, and this is it right here. Look at that. So once again, my name's Joey. You're watching Everyone Loves Math Live. That's what we got going in here, a little live show. And this is my website. It's everyonelovesmath.com. There it is. It's right there. So what you can do on everyonelovesmath.com, if you are looking for some online tutoring, I've got a link right at the top for you to sign up. Got my availability for the next 60 days up there. So go ahead and sign up for tutoring if you need it. Also has information about this live show that you're watching. If you just want some free help, come on down to the live show. I got you. All right. Yeah, there's a page with about me. I've been a teacher for a long time, and I've had some other roles in the math world as well, in the education world. All right. But tonight it's about math. And Stove, you've asked us another question. So here we go. I found it. All right. Stove, I know you have glasses. I think I'm getting close to getting glasses. I think it's coming. Like, it hit me real hard about this, like reading a pill bottle. And all of a sudden I look like grandpa. Worried, man. Yeah, it's rough. It's rough stuff. Let me tell you that. It's rough stuff. All right, so here is Stove's function, and they ask us some stuff here. All right, so it says, follow the steps for graphing a rational function. So they want us to graph this thing. All right, it says, if needed, and I'm just reading the instructions, if needed, first write the given function as a single rational expression. All right, so this already is a single rational expression. It's a single fraction. Okay, then factor the numerator and denominator of r of x. Okay, so select the correct choice below. So what they want to know is that can we continue to factor, or is rx already factored? Well, the numerator, here's how you tell. The numerator, this is a linear factor, x plus 5. There's no x squared, x cubed, so this doesn't break down anymore. In the denominator, you have a linear factor times a linear factor. There's no x squareds or x cubes that could possibly be broken down. So what you want to say is this, what they gave you, is factored. So you would pick B for this. This cannot be factored anymore. All right. So now, Stove, I think you can probably type into the chat, because they probably ask you to find something next. So they probably say, yeah, the domain. There we go. So let's talk about the domain. So in this problem, here's what you got to do. You always got to go back to, all right, if they're asking me about the domain, are there x's that are bad? Are there x's that make this thing explode? And so the thing that you have to remind yourself is whenever you have a fraction, you can't have 0 in the denominator. So if we're looking for domain, we want to make sure that the denominator is not 0. We got to make sure that that happens. So there are actually two numbers that make the denominator 0. One of them is if x itself is 0. Can't let that happen. Because if x itself is 0, then we would have 0 times 7. That would be a 0 in the denominator. The other thing that can't happen is x can't be negative 7. Because if x was negative 7, we would have negative 7 plus 7. So this would be negative 7 times 0, which would also be a 0 in the denominator. So the domain for this problem would be all of the x's except for those two. Okay, and I think you know how to type that in. Give me a second. My dog is done with math for the evening, so I'm going to let her out. All right, baby. See you later. All right. All right, Stove. So I think you should be good on the domain there. I'm gonna guess that they got some more questions. R of x in lowest terms. So this is in lowest terms. Yes, it is in lowest terms. There's no way to factor this anymore. Hopefully that was an answer. Yeah, when they ask about lowest terms, like if the numerator had been like, well, let's just say, let's pick pick the problem from the last one. Where was it? This problem here. This, as they gave it to us, was not in factored form. It was not in its lowest terms. We factored it to get this. So if that's all they're asking, there's nothing to factor with this thing. This thing's already broken down. We just got to do some math. That's where we're at. All right, x and y intercepts. So we're going to find the y-intercept, put 0 in for x, find the x-intercept, put 0 in for y. Okay? So let's do it. So if we're going to do the x-intercepts, x-intercept. So for the x-intercepts, we're going to set y equal to 0. So I'd write 0 equals x plus 5 over x times x plus 7. And by the way, what I'm doing eventually, you're going to be able to do in your head. I'm writing it out because I don't want to just say it all and have it, Okay. So just like the previous problem, and in fact, just like every problem basically in this chapter, in order to answer this problem, we need to think, when does a fraction equal 0? Well, a fraction equals 0 when its numerator equals 0. If we have 0 divided by something, now we're in business. So x plus 5 equals 0. That means x is negative 5. All right, so our x-intercept is where x is negative 5 and y is 0. So there's our x-intercept. So this particular problem only has one x-intercept. The last problem had 2 of them. All right, I think we can do the y-intercept off to the right here. So for the y-intercept, we're going to put 0 in for x. So we would get y equals, because we're putting 0 in for x, 0 plus 5 over 0 times 0 plus 7. Uh-oh. Uh-oh, SpaghettiOs. Uh-oh, SpaghettiOs. Look at this. Remember how 0 was one of the numbers that was bad? Remember that? When x is 0, that's bad. Because when x is 0, that puts a 0m in the denominator. So what we would say is this is bad. We should have we should have never been here. We should have never been in here. All right, it's like walking in on grandma in the bathroom. I should have never been here. You turn around and leave. So in this problem, we would say there is no y-intercept. Because we can't put 0 in for x. All right? And I'm sad about that. Oh, I'm sad there's no y-intercept. I'm going to guess next is horizontal and vertical asymptotes, if I had to guess. But we'll see. Stove will tell us. If I hum the hustle, they're saying there's more than one x-intercept. They're saying there's more than one x-intercept. Back in this problem, x plus 5. I'm going to zoom in again. The x plus 5, there is only one x-intercept. Do you want it, they need to put it in like as a point? Do you need to say for the x-intercept, negative 5 comma 0? It ain't cool, man. I don't, I'm not, I'm okay with somebody disagreeing with me, but let's see what the old website says. Cause you can tell him to forget about it. I found the x-intercept. And there is no y-intercept because x is not allowed to be 0. It makes Denominator 0, and that's bad. Bad. All right, it's coming through the tubes. Stove, I'm waiting. Here it comes. Just kidding. It actually, I would have no idea when it's on its way. But I'm refreshing. I'm refreshing the hotline right now. It's right here. Refreshing it. Do. Well, that'd be funny if I got... So, like, I can't use copyright music. I wonder if I hum copyright music, would it get taken down? Or only if I, like, hum it good enough? Like, maybe I'll try... I don't know. I think because I was kind of humming the Do the Hustle. I don't know why that was. It was like do 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 do. I don't think that'll get. I don't think that was authentic enough to get called out. Oh, here we go. All right, here we go. Boop boop boop. All right. I'm looking. Okay. Wow. Okay. I'm pulling it up now because this is a complicated one. Here we go. All right. The graph has okay. So stove type an O, use a comma. Okay. So I think stove, they just want you to type in the lazy x-intercept. So instead of typing in -5, 0, why don't you just type in -5? The x-intercept, because we could say, the like official thing to say is the x-intercept is the point -5, 0. But I think you can also say, I know you can also say this, the x-intercept is -5. So let's try to just type in a -5 and then we'll be good. All right, and the annoying thing here is the instructions said type an integer or a fraction. So yeah, they didn't want the point, they just wanted the number. Okay. Lame. All right, yeah. Are asymptotes next? I'm guessing asymptotes are coming to us, right? We're not ever going to escape the asymptotes. I should just start finding them. That's what I think. All right, I'm gonna get ready for your next question. I'm gonna get this thing copied back up here. All right, this thing was x plus 5. Oh, pick cent. Boom, boom. Here we go. X times x plus 7. All right, not asymptotes. All right. They ask you for something else. Let's see. All right. Boop. Do. All right. There we go. And there we go. Oh. Okay. Determine at any... Okay. So determine the behavior of the graph of R at any x-intercepts. Okay. Select the correct thing. Okay. So, weird. Okay, so what's going to happen? All right, so, man, what a weird question. All right, so we know the x-intercept is -5. So the graph will cross the x-axis at -5. And then the question is, let's see, and touch but not cross. Okay. Yeah, so what you would type in here is the answer would be B. The graph will cross the x-axis at x equals -5. And then what I would like to do is I'd like to talk about why before we move on. I want to go to Desmos. And let's talk about this for just a second, okay? So I'm going to go to Desmos, and I'm going to put this function in. So up top, we got x plus 5. And on the bottom, we got x times, parentheses, x plus 7. Okay? All right, so this is just homework, so I can always cheat and go to Desmos. But Stove, this is what the function looks like, and what they want you to be able to tell. And I think I can show it off with this. Nope, you still can't see that. Okay, if I do this and then do that, all right, so we can see that. So here is the x-intercept over here at -5. It's right there. And if you look at this rational function, what we said is true. This graph crosses the crosses the x-axis when x is -5, right? Like there it is. But a couple of the answers asked about mentioned x like touching at -5 and bouncing off. So let me tell you about when does it happen, when does the graph pass through the x-intercept, and when does the graph bounce off? Okay, so I can do something actually really small to this graph to make it bounce off at x equals 5, or x equals -5. What I'm going to do is I'm going to go, let's see here, back to Desmos. Let me get back into Desmos here. And all I have to do to make it bounce at -5, oh, where did I get my pointer back? There we go. There we go. So all we have to do to make it bounce is to make it x plus 5 squared. All right, so I'm going to make it x plus 5 squared, and look how the graph changes. Now this graph actually bounces at -5. It doesn't quite look like a parabola, not from zoomed out back here, but now this graph, instead of crossing the x-axis, now it just touches the x-axis at -5. And so here is the general rule. The general rule is when, and I think you had asked about this question earlier in the week, when there is, remember we talked about multiplicity? Whenever there is a multiplicity of 2, and that includes a multiplicity of 2, 4, 6, or 8. So if there's 2 copies, an even number of copies of a 0 or of a factor, then if there's an even number, then it's going to behave like a quadratic. It's going to bounce at that x-intercept. If there's an odd number, so that would be x plus 5 or x plus 5 to the 3rd power. If I change this to the 3rd power, notice now it crosses the x-axis again. It doesn't bounce. So if there's an odd number of them, it behaves like, this one, look in the neighborhood of -5, that behaves like a cubic. It crosses the axis. But if I change it to a 4th power, now once again, it's going to behave like an even function. It's going to bounce. So that is where you see multiplicity in a graph. The multiplicity of the 0 tells you information about if it bounces at that 0 or not. Okay, but there was the original function back again, and because -5 is a 0 of multiplicity 1, right? -5 only shows up once, then this thing crosses the x-axis. All right, it's a weird question. All right. Let's see. So that answers that one. So we would say, I think I said this, it would be B. We would say the graph crosses the x-axis at -5. Yeah, this is really what that multiplicity thing means. Is whenever, the easy way to remember it, now it wants vertical asymptote. Of course it does. So, all right. Well, let's talk vertical asymptotes. We're in open board. We'll go back to it. All right, vertical asymptote time. Here we go. So vertical asymptotes are connected. Remember, vertical asymptotes are the bad x's. So it's almost always those bad numbers in the domain unless something weird happens. And we'll talk about it when we get there. So with this thing, remember this was x plus 5 over x times x plus 7. So remember, I'm going to use red here. X equals 0. That makes the denominator 0, and x equals -7. That makes the denominator 0. And there's no factors that cancel with either of those in the numerator. So these are the equations of the vertical asymptotes. This function has vertical asymptotes at x equals 0 and x equals -7. All right, those are the real bad days, man. And by the way, we can go back and look at that graph. Does this thing have a vertical asymptote at x equals 0? You bet. Look at that neighborhood of 0, right? It goes heaven and hell, baby. And then over here at -7, it does the same thing. Heaven and hell. Those are vertical asymptotes. Okay? And there are two of them, 0 and -7. There are no positive vertical asymptotes. All right. I'm going to go out on a wild hunch and say it probably wants a horizontal asymptote now. I'm going to go on this wild hunch. Because if they're asking about vertical, then they ask about horizontal. You tell me. Oh Lord, I'll send a picture. Oh, I bet I know what they're asking in this one. I bet I know. I love it when I get a oh Lord. Oh Lord, I'll send a picture. Oh Lord, I'll send a photo. All right. Yeah, it makes it hard to ask these questions when everything's like piece by piece. That's frustrating. All right, I got it. I got your thing. Okay, so now it's this one. Boom, boom. All right. Determine the behavior of the graph on either side of any vertical asymptotes, if one exists. And we know there are two vertical asymptotes. Okay. Now we got this. This won't be too bad. All right. Let's see here. So then it says it approaches infinity on one side of the asymptote and infinity on the other. Okay. And approaches. Okay, so let's talk about the behavior on either side of the asymptote. So, stove, we can answer this easy. Okay, trust me, we can answer this easy. So, let's pretend that I totally didn't cheat and already graphed this. First of all, okay, I'm not going to look at that. Just pretend. Okay. So, here's the thing. We know. Let me tell you what we know. I'm going to give you a slightly longer answer, but not too much long. We know that this thing has a vertical asymptote where x equals 0. So I'm going to put a dotted line like right here at 0. Right? There's a vertical asymptote there. And then it has a vertical asymptote at x equals -7. Right? So I'll put it there. Okay? So far, so good, right? Vertical asymptote at 0 and -7. All right. So because this thing has, let's just talk about, I don't know, let's pick 0 first. All right, let's zoom in around the 0 part of this graph. So because there is a vertical asymptote at 0, then really there's only a couple of things that this graph could do. To the left of 0, this thing could go like, oh, that doesn't look good at all. Let me make that look prettier. I can do better. Because I'm trying to do asymptote. So this thing could like approach. It could approach like that. It could be going up to heaven, right? To the left side of 0, maybe this function is going down to hell. I don't know. It's doing one of those. On the right side of 0, maybe this thing is going to heaven. Or maybe this thing is going to hell, right? Those are really the options for what this function does in the neighborhood of 0. It either goes to heaven on one side and hell on the other, or maybe it goes to heaven on both sides or it goes to hell on both sides, right? Like, those are the options. So what we're going to do is we're going to test some numbers, but all we care about is positive or negative. We don't care about the specifics because we know this thing is going to heaven or hell, positive or negative. So we just have to test it for heaven or hell. So let's do this. Normally I would do this in my head, because once you do this a few times, it's not too bad at all, okay? But I'm going to write this out. So let's first, let's do to the right of 0. So to the right of 0, let's decide if it's heaven or hell to the right of 0. Notice that this is to the right of 0. So what I'm going to do is I'm just going to do some fake math with like 0.01, right? That's a number just a little bit to the right of 0. So let's do some math with 0.01. Okay, so I'm going to put 0.01 in for x back in the original problem. And like I said, normally I wouldn't even write this down. Oh, let me move my thing so you can see it. Okay, there we go. So I put a number just a little bit to the right of 0. And remember, the question that we're asking is heaven or hell. So let's see. In the numerator, we have 5 plus 0.0. Okay, that's going to be a positive number. So I'm not even going to like be all that careful. I'm just going to say, okay, the numerator is positive. The denominator, that's a positive number times a positive number. That's going to be positive. And positive divided by positive is positive. So what did we just figure out? We just figured out that when x is a little bit bigger than 0, the y values are positive. So if I go to my graph, it must be this one. We must be going to heaven because the y values are positive. So let me erase this one. All right, so just by testing a number, that told us which one to pick. All right, so now I'm going to save myself some space. And next up, we got to pick a number just to the left of 0. So I kind of smiled when I saw this. I'm just going to make these 0.01s negative. And now we're talking about a number just a little bit to the left of 0. Okay, and let's do that same math. Remember, we just care positive or negative because this graph is either going to heaven or hell. So let's see, 5 minus a tiny bit, so this would be positive. And then in our denominator, negative 0.001. And then 7 minus a little bit, that would be positive. So in this, for x just a little bit negative, just to the left of 0, we would have a positive divided by negative times positive. Well, that would be negative. So that would be this one. It's got to be this option. Boom, boom. And so it's not going to be this one. Okay. And so what we want to say is, I'm just reading the problem to get the language from the problem. It approaches infinity on one side of the asymptote at x equals 0 and negative infinity on the other. So that's a sentence, right? And that sentence does apply. It approaches infinity on one side, like the right side, and it approaches negative infinity on the left side. Okay, so we can say that. Now we have to figure out the same thing with -7. So here's what I would say. It's not always like, oh, one's up, so the other one's got to be down. You can't do that. So you have to kind of do it the real way. All right, so next up, what I'm going to do is I'm going to erase my little chicken scratch over here, and we're going to do the same thing for the neighborhood of -7. All right, so the neighborhood of -7, let's see. Oh, I'm going to go to my graph. So this function, this thing either to the left of -7, it either goes to heaven or it goes to hell because there's a vertical asymptote there. And on the right side of -7, it's either going to go to heaven or hell. That's what the graph's going to look like. All right, so let's test a number to the right of -7. So I'm going to pick like -6.99. Okay, so this would be -6.99 plus 5, and then -6.99 times -6.99 plus 7. So I picked a number just to the right of -7. And remember, this is either heaven or hell, positive or negative, so I don't have to try that hard. So let's see. -6-ish plus 5, that would be negative. And then the denominator would be negative times positive. Because, this is really close to 0, but this would be positive. -6.99 plus 7. So negative and positive. So what do we got? Negative divided by negative times positive, that's an negative over negative, that's a positive. So what this tells us about this graph is that when we're to the right of -7, we must be going to heaven because the y values are positive. So I'm going to erase this side. All right. So hopefully you're seeing, Stove, that this isn't hard. We're plugging in numbers and like we're barely caring what the answers are, right? So it's not that hard, but it is a pain in the butt to do by hand. It's a heck of a lot easier to use a graphing calculator. But, you know, the way they asked it, I want to make sure that you get it right no matter what. All right, so now we got to do to the left of -7. So I'm going to pick -7.01, right? That's just to the left of -7. And we're going to do all that same math, right? X plus 5, and then X, and then X plus 7, right? All right, so now it's time to consider this mental math, right? So -7-ish plus 5, that's going to be negative. Remember, I don't care what it's going to be. -7.01, that's going to be negative. And then -7.01 plus 7, that's going to be negative. Right? Think about this. This is going to be very tiny, but it'll be negative. And finally, if we have negative over negative times negative, that's 3 negatives. So 2 of them can make a positive. We'd still have 1 left over. This is negative, so it must be going to hell to the left of -7. So I'm going to graph it going to hell there. I'm going to erase going to heaven. Sorry. And now we can answer that question, right? So if we were going to describe... Oh, here we go. Let's sound smart. Let's sound like some college people. If we were going to describe the asymptotic behavior of this graph, we would say for the two vertical asymptotes, which occur at -7 and 0, the function approaches infinity on one side, and it approaches negative infinity on the other side. All right, and what we just did would give us a huge hint. I mean, look at this graph. This is really telling us if I put the x-intercept on there, we're really getting close to graphing this thing. So it is helpful what we did, even though, you know, we'd rather be somewhere else. I'd rather be nowhere else than here with you. All right, are we finally ready for horizontal asymptotes? It's been a while. They got to ask you about horizontal asymptotes eventually. Like, if that's not the next question, I don't know what is. Oh, so it will be B. Let me look here. So it approaches... no. It approaches... So, it approaches infinity on one side of the asymptote. So, Stove, you would have to pick A because there are 2 vertical asymptotes. So the answer for B, that only gives you a place to put in one of the vertical asymptotes. So because there are 2 vertical asymptotes, you would use letter A. So you would say it approaches infinity on one side of the asymptote at x equals 0 and negative infinity on the other. It approaches either infinity or negative infinity on both sides of the asymptotes at x equals -7. You want to be able to talk about both of the vertical asymptotes. All right, it doesn't like... Okay, that's fine. Let's see. I'm going to see what we got. Is it going to give us some nerdy stuff in here? All right, your Stove is sending a picture. It doesn't like that. I've got words for this program. I've got words for it. Let me add 'em, Scoob. That's what I say. Let me add 'em. Let's see. 949. There we go. All right. Let's see here. It approaches either on both sides of the asymptotes. How does it not like that? Weird. Okay. Huh. Huh. Stove. Okay. So this is, I mean, really right now, you and I looking at the multiple choice, this is like trying to pass the combination of like an English test and a test for psychic abilities. So type integers or simplified fractions, use a comma, type each answer only once. On okay. Okay. All right. So yeah, x equals. Okay, so Stove, I think you were right. I think you have to type in B, okay? And then I think you type in the answer 0, comma, -7, but that to me sounds like bad math. All right, I hope that's not what they want you to do, but maybe the answer is B, but you have to type in 0, comma, -7 because there's 2 vertical asymptotes. Yeah, so you said it was going to be B. Yeah, that's right. Okay. All right. But the thing is the way that they phrased it, I don't know. That question I would never ask that question. Whatever. Or I wouldn't phrase it that way. That's fine. Whatever. We got it, Stove. Stove, you got one more for me? Oh, horizontal asymptote. We're not done with this one. Okay. There we go. All right, horizontal asymptote. So, remember, horizontal asymptote. I'm going to do it down here. I'll do it in green, change my colors. So, horizontal asymptote is all about end behavior. All right, so let's look at this thing. Y equals x plus 5 over x times x plus 7. All right, so remember, end behavior is what happens if we put large numbers in for x, right? End behavior is what happens way out at the extremes. So, in the interest of time, and because I have a eraser, I'm going to erase the x's. And if I want to think about end behavior, then I'm going to put in 1 million for x. All right, so there I go. I did my bad math. I put 1 million in for x because I want to know what happens at the end for end behavior. Okay, so, let's see what happens. Well, the numerator, so what we, and Stove and I talked about a problem like this before. So in this problem, look at the numerator. The numerator is 1 million plus 5. This plus 5 doesn't even really matter. I mean, once you have 1 million, who cares about 1 million plus 5? Same is true in the denominator. In the denominator, that plus 7 doesn't really matter. Really, all we need to do is pay attention to where those x's were. So what do we have? Really, this fraction is 1 million in the numerator, which is big, but the denominator is 1 million squared. So like we could kind of do a little bit of fake math and like cancel out 1 million on top and 1 million on the bottom. Whatever you got to do to reason this out, the denominator is way bigger than the numerator, right? The denominator is like 1 million squared, and which is 1 million, and the numerator is just 1 million. All right, so because the denominator is a bigger power, right? It's 1 million squared. That means the denominator is going to get big quick, right? We're going to have, what this is basically going to tell us is if we put huge numbers in for x, it'll end up with smaller on the top and big on the bottom. And in fact, not just big, but like huge, gigantic. It gets real big down there. And if you have a fraction that is a small number divided by a big number, that gets really close to 0. So in this problem, the end behavior is y equals 0. So So what we did was we just kind of imagined very large numbers for x, and if we do that, then really we have the denominator way bigger. Whenever the denominator is way bigger, that means the fraction is 0. All right, and by the way, Stove, if I, just so happen to have been cheating, I can also look at the graph that we totally didn't do, and this confirms that the horizontal asymptote is 0. Look at this thing. As x gets bigger and bigger and bigger, the y value gets closer and closer to 0, to the point where, and I know I've done this before, you might think it actually equals 0 way out here, but watch your boy zoom in. Watch your boy zoom in. Look at that. You thought they were equal. They're close. They're real close. All right. Was that the last part of this super long problem? That was long. That was a long problem. It intersects the horizontal or oblique asymptotes. Oh, we aren't done. Okay. So does the graph intersect? Okay, so there is no oblique asymptote. All right, there's a horizontal asymptote. So now the question is, does the graph intersect its horizontal asymptote? Well, its horizontal asymptote is where y equals 0. Didn't we do that before? Didn't we say something that like when y equals 0, x was -5? This actually turned out to be the x-intercept. Remember that? Remember that when we found that number? We found that before. So, and by the way, BT dubs, check the graph. Look at this right here, right there at -5, 0. There it is. At -5, 0, this thing does cross its horizontal asymptote. Because in this neighborhood, we don't care about horizontal asymptotes. Horizontal asymptotes are only important way out here, and they're only important way out here. So the fact that this thing crosses its horizontal asymptote at -5, it was whatever. Okay? It's whatever. It's just a fact, I guess. We can say it's a fact. All right, Stove. Hopefully that answer worked. Or I should stop putting up my little cheater graph. Oh, holy cow, finally done. Man, that was a long problem, man. I'm gonna go get myself a Capri Sun after that problem. I need to rehydrate. You know what I'm saying? Yeah, Stove. Stove, do you have another one that you want to do? I can stick around and do one more, but if you've had it, then yeah, that was a strong Capri Sun. Yes, ma'am. Yeah, how do you feel? You want us to do one more? Are you good? Okay, cool. So I'll let you watch those videos and then we will check in next week. Yo, that was fun, man. That was fun. Stove, thank you for all those questions. And you can queue them up for Monday if you want, because that'll be our next show. Monday, 9 o'clock Eastern. All right? Yeah. And I'll see you next week, Stove. For everybody else, y'all stay classy out there. Have a great rest of your Thursday night. Have a great weekend. And yeah, we're gonna catch y'all. We're gonna catch you on the flip flop. Let me bring up my drum beat. Drum beat is coming up. Drum beat. See you later. See you later. Bye 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 bye.